Okay, today, horse of a different color in this video. You have 3 square root of 5, that means times, and then you got a plus sign, an addition operator, and then 6 times the square root of 5. Now, adding square roots is a lot different than multiply. You don't just add 3 and 6 and then 5 and 5. It's not like multiplication, okay? You don't add the insides, add the outsides. That's multiplication. This is clearly addition. So, above the addition sign, I want you to put like terms. That's what you're going for. Like terms means, I want you to write this over here just on this first problem, okay? The square roots must match to add, okay? The 6 and the 3 and the 6 have to be multiplied by the same identical square root, okay? Square roots must match. They do. They are both multiplied by the square root of 5. So what you do then is add the outside coefficients, okay? C-O-E-F-F-I-C-I-E-N-T-S. C-O-E-F-F-I-C-I-E-N-T-S. Add the outside coefficients. So they're multiplied by the same square root. So you write the square root of 5 down, and then you can add 3 plus 6. That's 9. Okay. So that one was easy, but then the subsequent ones you're going to have to do more work on. Okay. So 9 times the square root of 32 plus 5 times the square root of 8. So we have the addition sign, so we have to look for like terms. These are not like terms because the square root of 9 is multiplied by the square root of 32, 5 is multiplied by the square root of 8. So the coefficients I'm trying to add are not multiplied by the same square root, so the like terms, we don't have like terms. So what you then do is you make a little table, and on one side you put 9 times the square root of 32, and on the other side you put 5 times the square root of 8. And you're going to simplify both of these expressions so that your square roots match. So you have 2 coefficients multiplied by the same square root. So you simplify the square root just like you have been. Okay, the square root of 32. 32 is not a perfect square, so that's an irrational square root. So you put the division sign, and then I want you to carry your 9 factor down. And then you rewrite the square root of 32 as a square root times a square root. We need 2 factors that multiply to 32, but it has to be the first factor has to be the highest perfect square that 32 can divide by. So I go 32 divided by, and 32 would be right between the square root of 25, square root of 36. So we start dividing at the square root of 25. That's a decimal. 16, okay, 16 works, so I put 16 and 2, because 32 is 16 times 2. Now the square root of 16 is equal to 4. So we have 9 times 4 times the square root of 2. And now 9 times 4 then is multiplied to make 36, and then square root of 2. So replace 9 square root 32 with 36 square root 2, okay? Now we have to do the same thing here, 5 square root 8. So 8 is not a perfect square either. So there's no whole number times itself, that's 8. So I put IRR and divide. So that coefficient 5 drops down, but then we make the square root of 8 into square root times square root. So 8 divisible by 4, I think it is. So I put 4 and 2. And coincidentally, the square root of 4 turns into 2. So now I have 5 times 2 times the square root of 2, and then that coefficient then is 10, so 10 square root 2. So then we replace that with 10 square root 2. Now you have the like terms. Both the 36 and the 10 are multiplied by identical square roots of 2, so we now have the like terms, okay? So square root of 2, and then 36 plus 10 is 46. Okay, next problem. Times plus times. So To execute the addition operation, we have to have like terms. Now, we didn't have to have the like terms when we were multiplying. We just multiplied the coefficient, outside coefficients, and then the square roots. But addition's different. Okay, addition, you have to have like terms, which we don't have because that square roots do not match. So, on one side I put 8 times the square root of 6, and then 3 times the square root of 24. So, square root of 6. 6 is an irrational square root, so I put IRR and then a division sign. Okay, we drop the 8 down, and we see what 6 could divide by. Okay, so 6 divided by 4, well, that's not divisible, that's a decimal. 1 and 6, you bet. So 6 divides by 1 and you get 6. So the square root of 1 equals 1. Now, having a 1 as the outside coefficient, you don't really need that. So you just have 8 times the square root of 6. Okay, you don't multiply anything then. You could put 1 down here and take 8 times 1. It's still 8 though. Okay, so that just means when you get that 1 there, pretty much it was in simplest form to begin with. Okay, so this doesn't really get replaced. It just stays 8 square root 6. Okay, you can put the times dot if you want. Don't really need to. Now I hope the other one changes. Okay, 24 is not a perfect square, so if it's not a perfect square, then the square root value is irrational. So I put divided by, I drop my 3, and then square root times square root. So 24 divided by 16, nope. 9, nope. 4 and 6, so 4, 6. So the square root of 4 turns into 2. And we now have 3 times 2 times the square root of 6. So 3 times 2 then is 6, and we have the square root of 6. See, 3 times 2, that's 6. So we replace this with 6 square root 6. And now we have like terms. Okay, I'll just put LT for like terms. Okay, so we have the 8 and the 6 as your outside coefficients. They're both multiplied by the square root of 6, so we put the square root of 6 down, and then 8 plus 6 is 14. Okay, next problem. 6 times the square root of 18 plus 9 times the square root of 50. So with the plus, we have to have like terms. And we do not have like terms because the square roots don't match. The 6 is multiplied by something completely different than the 9 is multiplied by. So you go make your table, and you put 6 square root of 18, and then 9 square root of 50. Actually put times if you want. So 18, square root of 18, not a perfect square, so you put IRR. Okay. Then put the division sign, so you carry down your 6, and use square root times square root. So 18 divided by 16, decimal. 18 divided by 9, 9 and 2. So 9, 2. And then we replace the square root of 9 with 3. Now what we have is 6 times 3 times the square root of 2. And 6 times 3 is 18. 18 times the square root of 2. And you can't times a square root by a coefficient. Don't ever do that. So we replace this with 18 times the square root of 2. Plus, now we do the same procedure with the 9 times the square root of 50. Square root of 50 is not a perfect square, so that's irrational. So 9, put the division sign. So then 50 divided by, first we'd go 49, decimal, decimal, 25 and 2, okay. And the square root of 25 turns into 5. So we have 9 times 5 times the square root of 2, and then 9 times 5 gives me 45 times the square root of 2. So we replace this 9 times the square root of 50 with 45 times the square root of 2. And now we put the square root of 2 down, okay, because now we have like terms, okay. 18 plus 45 is 63. Remember, you can only add terms if they're multiplied by the exact same thing. Okay, next one. 5 times the square root of 20 plus 5 times the square root of 45, so like terms. So these 5s are multiplied by 2 completely different square roots, so you have to make the table and try to simplify. So 5 times the square root of 20 and 5 times the square root of 45. Okay, so you bring down your 5. Or 20 is irrational, you can see that. So IRR, it's an irrational square root, meaning it's a decimal that goes on forever, so you go divided by 5 times square root times square root. Okay, so 20 divided by 16, decimal. 20 divided by 9, decimal. 20 divided by 4 is 5, so 4, 5. The square root of 4 is equal to 2. So we have 5 times 2 times the square root of 5. Then 5 times 2 is 10, and then square root of 5 times the square root of 5. So replace 5 square root of 20 with 10 times the square root of 5. Okay, then 5 times the square root of 45. Okay, square root of 45 is irrational. So 5 times, put a division sign there, and you try to divide 45 by one of the perfect squares, the highest possible perfect square. 36 won't work. 25 won't work. 16 won't work. 9 and 5. So the square root of 9 is equal to 3. So we have 5 times 3 times the square root of 5. 5 times 3 then is 15, and then the square root of 5 next to it. So we replace this with 15 times the square root of 5. Now, my coefficients 10 and 15 are multiplied by the exact same thing, so I put the square root of 5 down, then 10 plus 15 is 25. Okay, 3 square root 8 plus 9 square root 50. Okay, so times here, and then the plus means we got to have like terms to add, LT, and then 9 times the square root of 50. Now, we do not have the like terms, they're multiplied by completely different things. Okay, so we make a table and try to rearrange them, simplify the terms, so that hopefully they are like terms. Okay, so the square root of 8. So we put divided by, because 8's irrational. The square root of 8 is 3. Okay, so 8 divided by 4 would be 2. So 4 and 2, but the 2, yeah. And then the square root of 4 turns into 2, incidentally. And you have 3 times 2 times the square root of 2. 3 times 2 is 6, and then square root of 2. So we replace this with 6 times the square root of 2. Okay, plus 9 square root of 50. So 50 is irrational. Okay, IRR. So 9 times square root times square root. So 50 divided by 49, decimal. 36, decimal. 25 and 2. Okay. So the square root of 25 turns into 5. You have 9 times 5 times the square root of 2. And then 9 times 5 is 45 times the square root of 2. That's 45, I just here. 45 square root of 2. So you write the square root of 2 down, and then 6 plus 45 gives you 51. 51 square roots of 2. It's like adding x's. Okay, you can't add a 3 to a 5 times x because they're multiplied by different things. Well, square radicals are no different. Okay, 2's multiplied by the square root of 12, then plus, that means we have to have like terms. 3's multiplied by the square root of 27. So these are not like terms, but they're not like terms yet. We can simplify radicals, so hopefully they are like terms. So 2 times the square root of 12, and then 3 times the square root of 27. So 12 is your irrational square root. So we put the division sign, and then we drop our 2, and then start dividing 12. 12 divided by 9 decimal. 12 divided by 4 is 3. Okay? And the square root of 4 equals 2. Okay? So we now have 2 times the square root of 3, and 2 times 2 is 4, square root of 3. So we replace 2 square root of 12 with 4 times the square root of 3, plus 3 times the square root of 27. Okay, so the square root of 27, that's irrational. So 3 times square root times square root. So 27 divided by 25 is a decimal. Decimal. Okay, 9 and 3. So the square root of 9 equals 3. So 3's are wild here. You got 3 times the square root of 3. So we multiply the 3 by the 3 to get 9 times the square root of 3. So 9 times the square root of 3. So you put down, now they're both multiplied by the same square root. Okay, so we put that square root down, and now we can add 4 plus 9, that's 13. Okay, last one. 8 times the square root of 5 plus 7 times the square root of 20. Again, you got to have like terms. We don't have those. Okay, so 5 is an irrational square root. So divided by 8 times square root times square root. Now the only thing 5 is going to be divisible by is 1. Okay, 5 divided by 1 is 5. Now remember, having a 1 coefficient, you don't need it then. So this is just 8 times the square root of 5. You don't actually end up multiplying anything. So really it just stays. If you know right away that the only thing this square root here is going to divide by from our perfect square list is 1, you know it's just going to stay the same. Okay, now over here, the square root of 20. Square root of 20 is irrational. So put the dividing sign. So, and you write it into 2 multiple square roots. So 20 divided by 16 decimal. 9's a decimal. And then 4. 4 and 5. So square root of 4 is equal to 2. So 7 times 2 times the square root of 5. So really that's 14 times the square root of 5. And now we have our like terms. Okay, they're both multiplied by the same square root value, square root of 5. Then 8 plus 14 is 22.